Good morning friends. Let me welcome you to my channel K Bansal. We were working out our problems from JEE Main 2019 Physics 11th of January 2019 morning session. Before going further, please press the subscribe button and don't forget to press the bell icon to receive the notification of all my future videos. Our next question is, an equilateral triangle ABC is cut from a thin solid sheet of wood as shown in the figure. D, E and F are the midpoints of its sides as shown, and G is the center of the triangle. The moment of inertia of the triangle about an axis passing through G and perpendicular to the plane of the triangle is I0. If the smaller triangle DEF is removed from the triangle ABC, the moment of inertia of the remaining figure about the same axis is I. Then our options are I equals 3 by 4 I0, I equals 15 by 16 I0, I equals 9 by 16 I0 and I equals I0 divided by 4. That's a nice question from rotation dynamics. Let us try to solve this question. Let A and capital M represent respectively the side length and mass of the triangle ABC. Then from the geometry, it is clear that the side length and mass of the triangle DEF are A by 2 and M by 4 respectively. Let moment of inertia of the triangle ABC, I0 equals K times of MA square. Then the moment of inertia of the triangle DEF, I1 equals K into M divided by 4 into A by 2 whole square, or I1 equals K into MA square divided by 16, which equals 1 by 16 into I0. Very clearly, the moment of inertia of the triangle ABC after removal of the triangle DEF, I equals I0 minus I1, or I equals 15 by 16 into I0. Our answer matches with option 2, therefore option 2 is the right answer. Our next question is, a body is projected at t equals 0 with a velocity of 10 meters per second and at an angle of 60 degrees to the horizontal. The radius of curvature of its trajectory at t equals 1 second is r. Neglecting air resistance and taking acceleration due to gravity equals 10 meter per second square, the value of r is. Our choices are 10.3 meters, 5.1 meters, 2.8 meters and 2.5 meters. Obviously, this is an interesting question from motion in a plane. So let's solve this question. Let us take the point of projection as our origin and the horizontal through the point of projection as our x-axis and upward vertical through the point of projection as our y-axis. Then u cos of theta equals 10 into 1 by 2 equals 5 meter per second and uy equals u sine of 60 degrees equals 5 root 3 meters per second. The vertical velocity of the particle after 1 second, vy equals uy minus gt, which equals 5 root 3 minus 10 equals 5 bracket starts root 3 minus 2 bracket closed, and vx equals 5 meter per second as there is no acceleration in the x direction. Let alpha be the angle that the velocity vector makes with x-axis, then modulus of tan alpha equals modulus of vy divided by Vx, which equals 2 minus root 3. The component of the acceleration perpendicular to the velocity vector is g cos of alpha. From the concepts of circular motion, we know that the radius of curvature r equals v square divided by g cos of alpha, or r equals 25 bracket starts 8 minus 4 root 3 bracket closed whole divided by 10 into a root of 8 minus 4 root 3, which on simplification gives me r equals 2.77 meters, which is approximately equal to 2.8 meters. So our answer matches with option 3, and hence option 3 is the right answer. Our next question is, in the figure shown below, the charge on the left plate of 10 microfarad capacitor is minus 30 microcoulombs. The charge on the right plate of 6 microfarad capacitor is. In this question, the diagram shows a 10 microfarad capacitor in series to which is connected a parallel combination of 6 and 4 microfarad capacitors, and in series to that is connected a 2 microfarad capacitor. Our choices are minus 12 microcoulombs, plus 12 microcoulombs, minus 18 microcoulombs, and plus 18 microcoulombs. Now this is a very simple question from electric potential and capacitors. Let's now solve this question. Let the charges on the 6 microfarad capacitor and the 4 microfarad capacitor are Q1 and Q2 respectively. Since these two capacitors are connected parallel to each other, the potential difference across each of them is same. That implies Q1 divided by 6 microfarads equals Q2 divided by 4 microfarad, equation 1. Furthermore, since the parallel combination of 6 microfarad capacitor and the 4 microfarad capacitor are connected in series to 10 microfarad capacitor, therefore the total charge on 6 microfarad and 4 microfarad capacitors is the same as that on the 10 microfarad capacitor. That implies that Q1 plus Q2 equals 30 microcoulombs, or Q2 equals 30 minus Q1. Substituting this value of Q2 in equation 1, we get Q1 divided by 6 equals 30 minus Q1 divided by 4, which on simplification gives me Q1 equals 18 microcoulombs. Now we have to work out, will it be plus 18 microcoulombs or will it be minus 18 microcoulombs? Since the charge on the left plate of the 10 microfarad capacitor is negative, therefore the charge on the left plate of the 6 microfarad capacitor will also be negative, and hence the charge on the right plate of the 6 microfarad capacitor will be plus 18 microcoulombs. Our next question is, there are two long coaxial solenoids of same length L. The inner and the outer coils have radii R1 and R2 and number of turns per unit length as N1 and N2 respectively. The ratio of the mutual inductance to the self-inductance of the inner coil is. The choices are N2 divided by N1 into R2 square divided by R1 square, N2 divided by N1 into R1 by R2, N1 by N2, and N2 by N1. This is a rather simple question from electromagnetic induction. Let us now solve this question. We know that the mutual inductance of this pair of coils is given by capital M equals mu naught into capital N1 into capital N2 into A divided by L, and the self-inductance of the inner coil is given by capital L equals mu naught into capital N1 square into A divided by L, where N1 total number of turns of the inner coil, N2 be the total number of turns in the outer coil. Substituting N1 equals small n1 into L, capital N2 equals small n2 into L, and A equals pi r1 square, we get capital M equals mu naught into small n1 into small n2 into pi r1 square into L, and capital L equals mu naught into small n1 square into pi r1 square into L. Dividing m by L, we get m by L equals small n2 divided by small n1, and our answer matches with choice 4. Our next question is, a hydrogen atom initially in the ground state is excited by absorbing a photon of wavelength 980 angstrom. The radius of the atom in the excited state in terms of the Bohr radius A0 will be given Hc equals 12,500 electron volt per angstrom. Our options are 16A0, 9A0, 4A0 and 25A0. This is a very simple question from structure of atom and can really be done very simply. Let's solve this question. The energy of the photon of wavelength lambda equals 980 angstrom is given by E equals Hc divided by lambda equals 12,500 divided by 980, which equals 12.76 electron volts. Let n be the quantum number of the excited state. Then delta E equals 13.6 bracket starts 1 by 1 square minus 1 by n square, or 12.76 divided by 13.6 equals 1 minus 1 by n square, or 1 by n square equals 1 minus 12.76 divided by 13.6, which equals 0.84 divided by 13.6, or n square equals 13.6 divided by 0.84, which equals 16.19, or n equals 4. We know that the radius of the nth orbit is given by Rn equals n square into A0, or Rn equals 16 into A0. Our answer matches with option 1, and hence option 1 is the right answer. Our next question is, a rigid diatomic ideal gas undergoes an adiabatic process at room temperature. The relation between temperature and volume for this process is Tv raised to power x is equal to constant. Then x is, our choices are 5 by 3, 3 by 5, 2 by 3 and 2 by 5. This is a rather simple question from the chapter on thermodynamics and can be done fairly simply. Let us solve this question. We know for an adiabatic process, Pv raised to power gamma is a constant, and also for an ideal gas, Pv equals nRT, or P equals nRT divided by V. Substituting this value of P in Pv raised to power gamma equals constant, we get T into V raised to power gamma minus 1 equals constant. But for a diatomic gas, the value of gamma is 7 divided by 5, so we get Tv raised to power 7 by 5 minus 1 equals Tv raised to power 2 by 5 equals constant. That clearly means that the value of x in the equation is 2 by 5. So our answer matches with option 4 and hence option 4 is the right choice. Students, please note that most of the teachers and institutes make you mug up a lot of formulae for everything. Whereas I personally believe that we must not mug up a number of formulae and should depend only on a few number of relations. For example, for an adiabatic process, PV raised to power gamma is the perfect equation and it can be changed into other forms using the ideal gas equation, that is PV equals nRT. This will help you not making any mistakes and it will not create any confusions. Important rule: only fools do physics with formulae and wise people do it with their brain, by K Bansal. So I hope you enjoyed this question, and in case you have any difficulties, please comment me in the comment box and I'll answer all your questions. Please don't forget to like, comment, share and subscribe this channel, and do visit us again for the next question. Till then, happy learning.